Okay, good day everyone. So this is our topic for this morning. So by the way, this is Engineer Jonathan Monterola. No? So our topic for this morning, for this video, is all about Ohm's Law. Okay. So what is Ohm's Law? What is Ohm's Law? So Ohm's Law, uh, this is from George Simon Ohms. So according to him, current in a resistor varies in direct proportion to the voltage applied to it, and is inversely proportional to the resistor's value or the resistance. So in short, current is directly proportional to the voltage and it is inversely proportional to the resistance. So this is this mathematical relationship between current, voltage, and resistance is shown below. So if you know two of the three quantities, so voltage, current, and uh, resistance, you can solve for the third, for the unknown. So this is the quantities, voltage, current, resistance, abbreviation VIR. Okay, then units, so volts, ampere, and ohms. Then symbols, V symbols or unit, A, and then ohms. So if one of the unknown is voltage, if voltage is unknown, so we can solve for the problem using this formula. So IR, V is equal to IR, and if the current is unknown, then you can solve for the problem using this formula. So this is the original, formula of Ohm's law. So you can see here the mathematical relationship of the variables. So I, or current, is directly proportional to the voltage but inversely proportional to the circuit resistance, to this one. And if the resistance is unknown, so you can solve the problem using this formula, V over I. So all of this derivation is coming from the original Ohm's law formula, I is equal to V over R. Okay, so we come up lang this formula is derived using this formula. So Ohm's law chart. So makita na to diri, you can see the relationship of the variables. So cover the quantity that is unknown. If ever voltage is unknown, so cover the V and then multiply, so IR. So VI is equal to IR. If I is unknown, then cover the I, and then so V over R. Okay, so V over R. If R is unknown, then cover that one, so V divided by I. Okay, so also example, the flashlight shown uses is 6-volt battery and has a bulb with a resistance of 150 ohms. Okay, so when the flashlight is on, how much will be the current drawn from the battery? So the schematic diagram of this problem is this one. So you have a source of 6 volts, you have a resistance or circuit resistance of 150, okay, and then the unknown is the current, current IR, for since usa naman, no, there is only one load of the circuit, so you can say that IR is equal to the total resistance of the circuit. Okay, so as you can see here, plus minus, that is the voltage drop, no, the voltage drop across the load. So solve, since I is unknown, so cover I. Okay, so V over R. So therefore, substitute, no, IR is equal to VR over R, since VR is equal to VT, which is equal to 6 volts. So 6 volts divided by 150 ohms. Therefore, this bulb, no, consume or drawn a current of 40 milliampere or 0.04 amperes or 40 milliamps. No? 40 milliamps. A lot of problems that we can solve, no? So here, bisan asaan nila ang unknown, so pwede na ito ma-solve. Like for example, given that the battery or the flashlight consumes a power of consume a resistance, no, or a current of 40 milliamps, and then you are going to solve what is the circuit resistance of the, or what is the resistance of the bulb, no? So R is equal to V over I na punta, no? So cover this one, so V over I na punta. So to solve for the resistance of the bulb. Let's have the second example of Ohm's law. If a music player uses 3 volts of electricity at current of 0.5, the resistance is how many ohms? Okay, so as you can see here, this is the music player. Okay, and then this is the schematic diagram. No? Based on the problem, you have the voltage source of 3 volts, and then you have the current drawing in the circuit is 0.5 amperes. No? So solve for the R. No? By the use of Ohm's law triangle, you discover the R. So R is equal to voltage divided by the current I. Okay, so to solve, so R is equal to V over VR over IR. So here VR is the voltage drop across the the resistance of the music player. Okay, so since there is no other component in the circuit, so VR is equal to VT, no? So substitute, we have 3 volts, no, for VR, and divided by 0.5 amperes. So the resistance of the music player, no, is equal to 6 ohms. Okay, that is how to solve, no, for the resistance of a circuit in using Ohm's law. Okay, let's have the third example. The third example is this one, a blender, no? If the resistance for a blender motor is 10 ohms while drawing a current of 2.5 amperes from the source, how much pressure or EMF, or that is in electromotive force or EMF, is needed to power the motor? Okay, so this is the schematic diagram. Okay, schematic diagram of the circuit. Okay, so we have, okay, unknown source, so the pressure or the EMF is unknown. The IR is equal to 2.5, no, 2.5, and then we have 10 ohms. Okay, 10 ohms for the resistance of the blender. So this is the blender. By the use of Ohm's law triangle, so since we are going to solve for the voltage, so let's cover the voltage. So therefore, the current multiplied by the resistance. Okay, so to solve, okay, VR is equal to IRR, no? So substitute 2.5 amperes, okay, 2.5 amperes times, okay, 10 ohms, no? 10 ohms. So therefore, the VR is equal to 25 volts. So VR is equal to 25 volts. Therefore, our VT is equal to 25 volts. Okay? So, usa raman ang component. There is only one component in the circuit. So, therefore, your VR is equal to VT. Okay? So, I hope you understand the topic. Okay? So, these are the three different situations that that you might encounter during the assessment. Okay? So, thank you so much, and see you in the other video presentation. God bless.